Welcome to solverfy.
In this question, we have a wheel that rolls without slipping and then is turning counterclockwise with angular velocity omega, angular acceleration alpha. And then there's a rod AB connected in this manner. And we need to determine the velocity and acceleration of point B on the rod at this instance. Okay, so just a few things before we start. We need to, so this distance is A, so this distance will be A root 3, okay, because that's something we need when we write down the position vector of B relative to A. Okay, so the wheel rolls without slipping, rolls without slipping, okay, which means that point P is the instantaneous center of zero velocity. Okay. Okay, so that means that at point A, the direction of velocity will be something like this. Okay. Okay, so this is kind of pretty standard. It's going to be minus A omega I plus J. Okay, so and then we can then determine VB. A is equal to VA plus omega AB cross RB relative to A. So so as we expect that the rod to turn clockwise. Okay. Yeah. So okay, so that's how we are going to approach the problem. So VB, and then looking at this situation, VB is going to the left. Similarly, AB is also going to the left. Okay, yeah. So then we have minus VB in the I direction is equal to minus A omega I plus J plus minus omega AB K cross the position vector of B relative to A is minus A root 3I minus AJ. Okay, so just continue. Minus A omega I plus J plus A omega AB. So I took out all the minus signs, it becomes positive. Then we have K cross I gives plus J. Okay, and then we have minus I. Okay, yeah. Then we group the terms, minus A omega minus A omega AB I plus A omega AB root 3 minus A omega J. Okay, comparing components. Okay, so from the Y component, we get omega AB is equal to omega over root 3. Okay, and then from the X component, okay, we know that VB is equal to A omega plus A omega root 3. Okay, so this is equal to 1.58 a omega. Okay, and then remember that this is to the left. Okay, so this is our velocity of point B. Okay, and next we move on to acceleration. Okay, so we have we need to find the acceleration of point A first. Okay, so it's going to be minus A alpha I plus J, and then plus A omega square I. Okay, so we just so point A is over here with alpha, so it has so and then it's rolling without slipping, so the center is going to the is accelerating to the left with A alpha acceleration, and then so at point A there will be the 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 not the tangential component, but so this is a translational component, and then you need to add the tangential components. That's why you get minus A alpha I plus J, and then the A omega square I is from the speed. Okay, so this is the A omega square. This is the minus A alpha I plus J. Okay, yeah. So that's how, and then you can group the components A alpha plus A omega square I plus minus A alpha J. Okay, so we can find the acceleration of B is equal to acceleration of A plus alpha AB cross RB relative to A minus omega AB square RB relative to A. Okay, so this is, we said that we set AB is to the left. Okay, and then so the acceleration of A and then we have the minus alpha AB K cross minus A roots 3I minus A J minus omega square over 3 minus A roots 3I minus AJ. Okay, so I'm going to continue. A omega square minus A alpha I minus A alpha J plus A alpha AB minus I plus roots 3J plus omega square over 3 A roots 3I plus AJ. Okay, now we can group the terms. So we have A omega square minus A alpha minus A alpha AB plus omega square over 3 A roots 3 I and plus minus A alpha plus A alpha AB roots 3 plus A omega square over 3 J. Okay, so this is equal to minus AB I. Then we can compare components. Comparing components. Okay, we get two equations. no. Okay, so from the y component, yeah, from the y component, so yeah, it's true that we get two equations. Okay, so from the y components we get minus a alpha. So we need to determine alpha ab. Okay, so a alpha ab root 3 is equal to a alpha minus a omega square over 3. Okay, so alpha ab is going to be 0.577 alpha minus 0.193 omega square. Okay, then from the x component, we have AB is equal to A alpha minus A alpha AB plus A alpha AB minus A omega square minus A omega square over root 3. Okay, so if you put in A alpha plus A times 0.577 alpha minus 0.193 omega square minus A omega square, there's an A here, 1 plus 1 over root 3. Okay, then you get 1.58 A alpha minus 1.77 A omega square. Okay, so this is the acceleration of point B. Okay, note that this is to the left. Okay, and so that's all.